flow as well is kind of through HTTPS channels. So I think in terms of encryption, we are not kind of actively encryption. It's a lot of data to actually encrypt it and store it, right? So in terms of security, we're making sure that this data is not or directly accessible through the network. We are making sure that it's all only available through our API, and then we have a lot of security in terms of who gets access to the API. We have some security protocols out there.
So just to add an industry perspective on the security thing, the DMPs that I deal with, they just avoid PII like the plague. They make sure there is not a single scrap of PII. They never ingest it. If they see a phone, anything that looks like a phone number, an address, a name, an email address, they simply keep it out of their system. And that keeps them from the worst excesses of having to do any kind of compliance testing and stuff. So,
right. Just in light with the target breach and a lot of the recent security breaches, that's why I asked a security question.
So, I'm going to ask you a question which is probably very general. So how do you compare this Aerospike with any other NoSQL databases, especially things like Cassandra, other things in the world? And then specifically on that is, without this SSD layer, how do you compare yourselves with others?
So, I think Ryan would add to that, but so the Aerospike layer, for the Aerospike layer, we require a very, very high QPS. And the data resides mainly in the memory and then on the SSD disks. And we have been working with Aerospike since last 3 years, I guess. So the reason why we chose Aerospike is because the QPS that we wanted was pretty high. So we do close to 300 requests per second to the Aerospike store. If you consider, and today no other store is capable of handling that much amount of requests at that scale. So I think when we decided to go to a server-side store for handling our cookie information, I think we were lucky to have Aerospike there, and we started using that store, and it has been handling a lot of QPS. So I think it's mainly because of the QPS that it could handle. Is that the decision? Brian, do you want to add?
Usually what happens when, so I remember the folks at Pubmatic started using us because the folks at Comlink were starting to use us. I think that's how you guys heard about us. And the nice thing about Cassandra is you can get high performance, but it often requires just rolling out a huge number of servers. So that's one of the things that's often an issue is as you're rolling out more servers, your management goes up. You can script everything, but it's just more and more failure points. So I think that was one of the reasons why the Pubmatic guys liked us after hearing about it from the company guys.
Have you considered using Spark for anything? Did you see any value in that?
Yes, so I think we are doing some POCs. I think the good thing about Spark is it has support for ML algorithms, right? So it has an inherent support for powering your ML models. I think that is one use case that we are actively working on or trying to do a POC. The second thing that I already mentioned, right? Like Spark streaming is very exciting, and we want to tie up our Kafka or Kinesis with the Spark streaming and try to build our own stream processor which would power our real-time analytics, which we are also planning to power our algorithms with. So I think if we can power our ML algorithms with that real-time stream, and if we can use that algorithm or logic to kind of make more value out of the impressions, that is something that's going to be very helpful. I think that is one use case that we are actively looking Spark into. So we are looking at Spark. Yeah.
A question about latency for the real-time analytics engine, and
characterize in general latency through the system?
Yes, so our end-to-end latency of us getting an impression to serving an ad is close to 300 ms. So we have to respond within 300 ms with an ad which will deliver the highest value. So if you split that 300 ms, we require around 100 ms for our RTB. So RTB is sending 15, 20 requests for a particular impression and getting that response back. So we allow our RTB partners to respond within 90 ms, 100 ms, out of which 30 ms is the connection time. We mostly use persistent connection. So once the connection is set, you would just do a request response. You get that response. So that, plus we have a lot of algorithms that are in place. As I mentioned, after we receive the bid, we would filter out the bid based on the brand violations that the publisher would not want to see. There is a rule priority engine which basically prioritizes a certain deal versus another. So we have to run that through that algorithm. So those will take that much time. Those will take few ms. And then if we are looking at users, we are expecting that response to be there within 10 to 15 ms. So if you're looking at a certain user or certain entity from our store, we expect that to be reaching us within 10 to 15 ms, and we would use that information. So overall, it's a very, very high, I would say the latency needs to be, so all the elements involved in the actual auction needs to be very, very high performance in terms of latency. Does that answer your question?
Yes, it does.
So I'm a little confused between the real-time analytics question that you just answered for the algorithms versus analytics that you're running on the logger data. Where does data torrent fit in? Because it typically runs on a Hadoop cluster yarn,
Yes.
2.0, right, for streaming.
Yes, so the data torrent is basically powering our UI analytics. So on the UI, we are so when the ad gets delivered, that information flows through the system, and we show in the UI every 3 or 4 minutes how many impressions are logged for this particular advertiser, for this particular demand on your site. So the data torrent system is actually powering our UI. It's not powering our algorithms. For algorithms, we are storing information in a high performance store. It's queried by our ad server during that time.
Right, thanks.
So just a simple quantitative question. You mentioned so just a simple quantitative question because there's a couple of numbers that you put out at different times that I'm curious how they're gonna tie together interestingly. One is the 250 billion or 2.5 times 10 to the 11th real-time bids, real-time bidding auctions per day, and which is roughly 2.5 million a second.
Yeah.
So you also mentioned one number for the throughput on I guess it was on Aerospike, which is about 300 requests a second.
Yeah.
So how do you is that one instance of Aerospike? Which I guess what I'm trying to do is say, map. Okay, there's a certain throughut on Aerospike for any given instance.
Right. So
you have a much higher throughput than your whole platform.
Right,
so I'm
right,
curious
right.
about the mapping there.
So we handle close to 20 billion impressions, right? Those impressions at the peak time, if you consider the peak time, we would be handling close to 400K requests per second, and close to, and so not for all the requests we would be hitting our spike clusters, right? So we are currently looking up for say 70% of the time. So that flows comes down to around 250 to 300,000 requests per second on an Aerospike cluster. So does that, I mean, so it's close to 300,000 requests per second on Aerospike, not 300.
Okay,
That's-
sorry, I missed the digits
Yeah.
there.
Yeah.
Thanks.
I missed the K2.
you've got the bidding process, but is there any data mining or ad targeting as far as who sees what impression and what kind of algorithms are being used or software systems?
Is this, sorry, I didn't get the.
So is there any kind of forecasting or predictive models? So that when I'm looking at a publisher webpage, you say, oh, Greg is most likely to respond to X.
Right.
Type of thing. I mean, I know there's bidding, and the bidding might be based on some rules, like
Right.
people that are in this age and this gender, but those are kind of top down. Is there any bottom up targeting?
Right, so actually we are currently working on one of those models currently. We have certain ML algorithms which predict the eCPM. So we have these algorithms, so if an impression is coming from a certain geo, we would predict an CPM for that. So those kind of algorithms are in place, the geo CPM, the frequency capping model. So some of these algorithms are already in place. We are currently working. So the problem is the user segment is a very large cardinality, right? You are dealing with thousands of segments, and to precisely figure out that this segment is of this value, it takes a lot of learning. We are working on certain models currently to power our algorithm, but that is again in progress. But what we have right now are CPM, forecasting models. So based on the geo, based on the frequency, we would be finding the appropriate CPM. So.
Okay. I have a related question, which is, so since a lot of people here are involved in this exact kind of predictive analytics, maybe you can tell us a little bit about what that flow looks like. So you've got a set of rules. Even to put any rule in play, you have to know that it's going to be actionable. So sort of what's that feedback cycle like just to put any kind of rule in place? How long does it take to look at it? What kind of flows do you use to actually analyze success or failure of individual rules?
Right, so I think there's a lot of data mining that goes through. So we are collecting information, like for example the geo CPM. So we are collecting information about the impressions coming from different geos and what are the CPMs that the networks are paying for that CPM. So we collect that data, we crunch that data over the time, and then there are ML algorithms which will be crunching that data and figuring out what is the average CPM for a certain geo, for a certain type of vertical, and this process takes a long time. Like to accurately predict that CPM, it takes certain amount of cycles to crunch that data. We typically roll it out on a certain amount of inventory to test this algorithm out. So we would test it out on few small publishers to check out whether this is working. There would be some more additional points that would be involved. So we would be perfecting this algorithm over the period of time until it can be rolled out to a lot of other customers. So I think that's a huge cycle. Typically, an ML algorithm getting live is a bigger deal in terms of the amount of analysis that we need to do and the amount of testing that we need to do in the system.
Why did you pick Cuba for the ad hoc data analysis?
Again, I would. We got this idea from one of our other partners who are using Cubol, and we analyzed the platform and we found it very useful. So we did a lot of POC on that. We gave a lot of training. We had a lot of users working with Cubol, a lot of non-tech users working with Cubol and filing queries to crunch the data. And it was after that kind of we decided that it has to be an external system which does ad hoc reporting rather than doing it on our own flow.
So I have a question back here. Maybe this is an easy question, maybe it's a difficult question because you don't know the answer to the breaks, but it looks like you're well prepared for scale out and getting bigger. What do you think is going to break first when you get bigger and bigger and bigger?
That's a very good question. I think we have seen a lot of this impression growth. So we were doing close to 3 billion impressions sometime mid of last year, and we've grown from there to 20 billion. I think in our old platform, what we have seen to have kind of failed first is our ingestion, right? So ingestion is one of the trickiest thing. Like you have to be very, you have to monitor it very well, and you have to make sure that the capacity at which you're ingesting is calculated very well. In our old system, we had our own mechanism for ingestion. So we used to store data onto disks, and then we used to sync those to our HDFS. So at a lot of times you see that some of the machines have stopped responding because there's either disk full or the network capacity is not reaching well, etc. So that was, and ingestion, as I said, is the most critical points in your system. If that fails, it stops the entire show. So ingestion is one thing. Another thing that we have seen over past few years is with the growth in this industry, we were analyzing a few, like 10 dimensions or 20 dimensions, and currently we analyze more than 80 to 90 dimensions, in the sense that we used to work with ad networks and DSPs, but now we need analytics at a very granular stage, which is each buyer under that DSP, each advertiser, each user, each segment. Like so it's not only scaling at the data level, it's also scaling at the granularity, like the top down. So one of the things that we saw there was we were doing this tiered processing with our jobs, with our Hadoop jobs, and we kind of came up with a model which would suffice a lot of our reports. But over the time, we saw that model was sufficing only 60% of the reports, and we were doing a lot of analytics on our raw data, which was terabytes of data, and that was using a lot of our processing capacity. So I think that is one layer that you also have to take care about, that you have to reconcile your models, and you have to keep thinking about this model and make sure this model is up to date, rather than having users write queries on the raw data and start getting things. So I think reconciling models and making those models available so that you reduce the crunching time is something that we've also kind of seen over the past. What else? Yeah, I think these are like two critical things. One is your ingestion, the other is your actual crunching.
So I have a question. You mentioned
one more question and a concluding question.
Right. So you said 300,000 queries per second on Aerospike, right? So how many nodes of Aerospike are you using, and did you select the number of nodes for the data capacity or to meet the query requirement?
For both. So we always keep at least 40% of extra capacity than our server, because more than the peak. So when I say peak, our average impressions would be 100K per hour, but our peak would be somewhere around 250 or 3. Peak would be way more than that. It would be 3 times what we see in our regular, 2 to 3 times that we see on a regular period. So we always plan capacity which is 30% higher, 30 to 40% higher than the peak. So to answer your question, I think it's both. It's the QPS as well as the amount of data storage that we require. Currently we have 30 nodes spread across 5 different data centers which are running Aerospike.
So is 30 per data center? Or?
No, 30 across. So we close to, but it differs. Like one of the data centers has more nodes, the other has lesser nodes.
Brian, any concluding thoughts, question?
Just one. So, we've talked a lot about the behavioral and sort of taking sort of standard sort of pixel data. I was wondering if Pubmatic also uses sort of outside data sources like tweets, social media information, weather. You guys do any of that kind of stuff yet, or is that a future?
No, that data would come to us. So a lot of companies are already doing that, crunching, and they are segmenting the users. So I think that data comes to us in some sort, in terms of the segment data, but not like Pubmatic actually is not going out and looking at the tweets and organizing that data. So yeah.
Okay, great.
Awesome. Thank you both. Thank you, Kunal. Please join us next Wednesday for more about UAVs and drones. Thank you.